The prospect of colonizing Mars represents one of the most exhilarating and ambitious goals in the realm of space exploration. This vision of establishing a human presence on the red planet has transitioned from the pages of science fiction to the drawing boards of modern space agencies and private aerospace companies. This video examines the future of space travel and the colonization of Mars, highlighting the latest developments, plans, and challenges laid out by leading space organizations. The pursuit of Mars colonization is driving rapid advancements in space technology, addressing the unique challenges of interplanetary travel and habitation. Revolutionary developments are being made in propulsion systems, spacecraft design, life support, and habitat construction, each playing a critical role in turning the vision of Mars colonization into a feasible endeavor. In propulsion technology, significant strides are being made to increase the efficiency and reduce the costs of space travel. The development of powerful and reusable rocket engines is at the forefront of this effort. For instance, SpaceX's Raptor engine, designed for the Starship spacecraft, is a key innovation in this area, utilizing methane and liquid oxygen for fuel, which could potentially be sourced from Mars itself for return journeys. The design and engineering of spacecraft have also seen substantial innovations. Spacecraft like SpaceX's Starship are being designed to carry large crews and cargo, essential for establishing a sustainable Martian colony. These spacecraft feature advanced heat shield technology for re-entry, large living quarters, and the capability to land and take off from both Earth and Mars. Life support systems are another crucial area of advancement. Technologies are being developed to recycle water and air efficiently, crucial for the long-duration missions required for Mars travel. Advanced waste management and food production systems, such as hydroponic and aeroponic systems, are also being developed to support life in the closed environments of space habitats. Habitat technology is evolving to address the challenges of the Martian environment. Concepts like inflatable habitats, 3D printed structures using Martian soil, and radiation-shielded living quarters are being explored. These habitats need to be self-sustaining, providing protection against Mars' extreme temperatures, thin atmosphere, and high radiation levels. Robotics and autonomous systems are playing an increasingly significant role in space exploration. Rovers, drones, and automated systems are being designed to perform tasks such as site construction, resource extraction, and scientific research, both in preparation for human arrival and in support of manned missions. Communication technology for deep space missions is also advancing. High-bandwidth, reliable communication systems are essential for navigation, data transmission, and maintaining contact between Mars, spacecraft, and Earth. In summary, the advancements in space technology are rapidly transforming the prospect of Mars colonization from a distant dream into an impending reality. Each technological leap brings us closer to overcoming the immense space agencies around the globe are actively charting the course for human exploration and eventual colonization of Mars. These ambitious plans are backed by a series of missions and technological developments, each designed to lay the groundwork for the monumental journey to the Red Planet. NASA, the United States Space Agency, is at the forefront of Mars exploration efforts. Its Artemis program, aiming to return humans to the Moon by the mid-2020s, is seen as a vital stepping stone toward Mars. The experience and knowledge gained from establishing a sustainable presence on the Moon will provide invaluable insights for the longer and more complex mission to Mars. NASA's long-term goal is to send astronauts to Mars in the 2030s, an endeavor involving developing deep space habitats, life support systems, and new propulsion technologies. The European Space Agency, ESA, is also deeply invested in Mars exploration. Collaborative efforts like the ExoMars program, conducted in partnership with Roscosmos, Russia's space agency, are crucial in this endeavor. ExoMars comprises robotic missions focused on understanding the Martian environment and testing key technologies required for future human missions. ESA's Mars missions are also pivotal in the search for signs of past or present life and understanding the planet's geology and atmosphere. Roscosmos has expressed its ambition to be part of the international effort to explore Mars. Alongside its collaboration with ESA, Roscosmos is exploring concepts for future manned missions to the Red Planet, potentially leveraging its experience in long-duration spaceflight and spacecraft engineering. China's space agency, CNSA, has rapidly become a significant player in space exploration. Following the success of its lunar and Mars rover missions, CNSA is reportedly developing plans for manned lunar missions and has expressed long-term aspirations for sending Chinese astronauts to Mars, signaling its commitment to being a key participant in the future of space exploration. SpaceX, though not a government agency, is an essential contributor to Mars exploration. Elon Musk's vision of colonizing Mars is driving the development of the Starship spacecraft, intended to transport humans and cargo to the Red Planet. SpaceX aims to launch its first uncrewed mission to Mars in the next few years, with the ambitious goal of establishing a permanent human presence on Mars within the next couple of decades. In addition to these major players, agencies from other countries, including India's ISRO and the UAE Space Agency, are also contributing to Mars exploration, either independently or through international partnerships. These missions range from sending orbiters and landers to developing new technologies for future manned missions. In conclusion, the plans and missions of global space agencies represent a coordinated and escalating effort to explore, understand, and ultimately colonize Mars. These endeavors, marked by international collaboration and competition, are laying the foundation for one of humanity's most ambitious journeys, pushing the boundaries of our exploration capabilities and expanding our presence in the cosmos. The involvement of the private sector in space exploration, particularly in the journey to Mars, marks a significant shift in the landscape of space endeavors. Private companies are not only supplementing governmental space programs but are also pioneering their own ambitious projects for Mars exploration and colonization. This surge in private sector participation is driven by a combination of technological advancements, entrepreneurial vision, and increasing commercial opportunities in space. SpaceX, under the leadership of Elon Musk, is at the forefront of this new era of space exploration. Musk's vision of colonizing Mars is the driving force behind the development of the Starship spacecraft, designed to carry humans and cargo to the Red Planet. Starship's innovative design, emphasizing reusability and high payload capacity, aims to make space travel more affordable and frequent. SpaceX's timeline for Mars is aggressive, aiming for the first uncrewed missions in the near future and human missions potentially within the decade. Blue Origin, founded by Jeff Bezos, is another key player in the private space sector. While its immediate focus is on suborbital spaceflight, Blue Origin has long-term ambitions for space colonization. Its development of the New Glenn orbital launch vehicle and the Blue Moon lunar lander are steps towards establishing a sustainable human presence in space, with Mars being a potential future target. Boeing, a long-standing contractor for NASA, is also actively involved in developing technologies for deep space exploration. The company is working on the Space Launch System (SLS) for NASA, which is expected to play a pivotal role in future Mars missions. Boeing's expertise in spacecraft and systems engineering contributes significantly to the overall efforts in reaching Mars. Other companies, such as Lockheed Martin and Northrop Grumman, are involved in various aspects of Mars exploration, from developing spacecraft and technologies to participating in Mars missions. These companies are leveraging their decades of experience in aerospace to contribute to the Mars exploration efforts. Emerging players in the space industry, such as Relativity Space and Rocket Lab, are also showing interest in interplanetary missions. Their focus on small launch vehicles and 3D-printed rockets could open new avenues for cost-effective and rapid deployment of satellites and probes useful in Mars missions. The involvement of the private sector in Mars exploration is not without challenges, including technical, financial, and regulatory hurdles. However, the innovative approaches, competitive spirit, and vision of these private entities are propelling humanity closer to the goal of Mars colonization. Their participation is catalyzing advancements in space technology, lowering costs, and potentially making space more accessible than ever before. In summary, the private sector's involvement is revolutionizing the field of space exploration, bringing new resources, technologies, and perspectives to the long-held dream of reaching and colonizing Mars. This collaborative effort between government agencies and private companies is setting the stage for the next major leap in human space exploration. Colonizing Mars presents a myriad of daunting challenges, each requiring innovative solutions and significant advancements in space technology and human adaptability. These challenges span across various domains, from the technical difficulties of interplanetary travel to the sustainability of life on the Martian surface. The lengthy journey to Mars, taking approximately 6 to 9 months with current technology, poses risks from prolonged exposure to cosmic radiation and microgravity. Cosmic radiation can lead to increased cancer risk and other health issues, while microgravity causes muscle atrophy and bone density loss. Developing effective shielding against radiation and countermeasures for the health effects of microgravity is crucial for the safety of astronauts. Upon arrival, one of the primary challenges is the harsh Martian environment. The planet's thin atmosphere, composed mostly of carbon dioxide, provides little protection from solar and cosmic radiation. Additionally, the extreme temperatures, which can vary from 125 C to 20 C, and the lack of liquid water on the surface make Mars a hostile environment for human life. Creating sustainable life support systems is another critical challenge. These systems must efficiently recycle water and air while providing food for the crew. Advances in closed-loop life support systems, hydroponics, and other forms of space agriculture are essential to ensure long-term sustainability on Mars. The development of habitats capable of withstanding Mars conditions is also a significant challenge. These habitats must protect against radiation, provide adequate living space, and be resilient to the planet's dust storms. Utilizing materials available on Mars, such as regolith, for building habitats, could reduce the need to transport materials from Earth. Psychological and social challenges of long-duration space missions are as significant as the physical and technical ones. The isolation, confinement, and distance from Earth pose risks to the mental health and well-being of Mars colonists. Ensuring the psychological health of the crew requires careful selection, training, and support systems, both during the journey and on Mars. Establishing reliable communication systems for interplanetary distances is crucial. The delay in communication between Mars and Earth can range from 3 to 22 minutes, complicating real-time support and decision-making. Robust communication systems are essential for mission operations, scientific data transmission, and maintaining morale among crew members. Developing in situ resource utilization (ISRU) capabilities is vital for Mars colonization. ISRU involves using Martian resources, such as water ice and atmospheric carbon dioxide, to produce water, oxygen, fuel, and building materials, reducing the dependence on supplies from Earth. In conclusion, colonizing Mars is a complex and multifaceted endeavor that requires overcoming a host of technical, environmental, and human challenges. Addressing these issues involves not only advancements in technology and science, but also a deep understanding of human physiology and psychology. The successful colonization of Mars would be a monumental achievement for humanity, marking a new era of space exploration and human presence in the cosmos. The ambition to colonize Mars involves not just technological and scientific challenges, but also a myriad of ethical and logistical considerations. These aspects are crucial in ensuring that the venture into interplanetary colonization is conducted responsibly, sustainably, and with due regard for the broader implications on humanity and Martian environments. Ethically, the colonization of Mars raises questions about the treatment of potential Martian life forms and the preservation of the planet's environment. The principle of planetary protection is key, aiming to prevent biological contamination of Mars by Earth organisms, which could jeopardize the search for indigenous Martian life. This principle also encompasses the reverse scenario, protecting Earth's biosphere from potential extraterrestrial contaminants. The legal and ownership issues associated with colonizing Mars present complex logistical challenges. Current international space law, primarily the Outer Space Treaty, provides a basic framework, but it does not fully address the nuances of prolonged human presence and utilization of Martian resources. The development of a legal structure governing resource usage, habitation rights, and environmental responsibilities on Mars is essential. Resource allocation and management are crucial logistical considerations. Ensuring a fair and equitable distribution of resources among various Mars missions and between public and private entities will be vital. This includes the management of essential elements such as water and building materials, as well as the shared use of infrastructure and data. Societal and cultural impacts of Mars colonization are also significant. The endeavor will influence global perspectives on space exploration, international cooperation, and our place in the universe. It raises questions about the long-term societal implications of establishing a human presence on another planet, including the potential for new cultural and societal norms to develop independently of Earth. The psychological and ethical implications of raising the first human beings on Mars, who may have a fundamentally different experience of life compared to Earth-born humans, is another area of consideration. This includes the rights and responsibilities of these individuals and the nature of their relationship with Earth and its inhabitants. Transportation logistics, both to and on Mars, are crucial for the success of colonization efforts. This involves not only the safe and efficient travel of humans and cargo, but also the establishment of transportation infrastructure on Mars to facilitate exploration, construction, and resource gathering. In conclusion, the ethical and logistical considerations of colonizing Mars are as diverse as they are complex. They encompass environmental stewardship, legal frameworks, resource management, societal impacts, and the psychological well-being of colonists. Addressing these considerations is essential for the responsible and sustainable advancement of human presence on Mars, ensuring that this monumental endeavor benefits all of humanity and respects the integrity of our cosmic neighbor. The journey to Mars symbolizes the pinnacle of human exploration and ingenuity. With the rapid pace of technological advancements and growing interest from both government space agencies and the private sector, the dream of Mars colonization is closer to reality than ever before. However, the success of this endeavor depends on overcoming significant challenges and addressing ethical considerations. As we stand on the brink of this new era in space exploration, the journey to Mars promises to be one of the most defining ventures of human civilization in the 21st century.